question number 34. We have points A, B and C, and we need to find out the current through C resistors. We are given that the voltage at A is 30 volt, voltage at B is 12 volt, and voltage at C is 2 volts. So how do we solve this problem? There are, let's say, that is, I am putting a variable I1, which is the current through this 20 ohm resistor, and that's something we need to find. And we can find this if we know the voltage at X. So let us say the voltage at point, at this junction point, is Vx. And if we can find Vx, we can find the current flowing through this branch XB by doing Vx minus Vb divided by the resistance. And we also need to find out the current flowing through this resistor. Let us say it's I2. We can find I2 if we can find the voltage at X by Vx minus Vc divided by 30 ohm. And finally, because this current is flowing I1, this is I2, then this current that is coming into this branch must be I1 plus I2 using Kirchhoff's law. Now, what we are going to do is just write simple Kirchhoff voltage law equations. For this branch AX, we have the voltage difference between point 30, this A and X is 30 minus Vx. And that will be equal to the drop due to this is the only resistance, and the drop on this resistance will be I into R, I1 plus I2 multiplied by 10 ohm. In the same way, we can write the Kirchhoff voltage law equations for this branch XB. The voltage is Vx minus 12 is equal to the current flowing through this I1 multiplied by the resistor 20. In the same way, we can write the equation for this. Vx minus Vc, which is 2 volt, is equal to I2, the current flowing through this resistor, multiplied by the value of these two resistors. So we have these three equations, and if we can solve it for finding the value of I1 and I2. So we will start by first calculating Vx. So we take this equation here, and we will substitute the value of 20 I1 and 30 I2, and that will give us Vx. The equation will convert only in terms of Vx. So multiply this equation by 60 I1 plus 60 I2 is equal to 6 into 30 minus Vx. We multiply the equation by 6. Now 20 I1 is equal to Vx minus 12. So we create 3 into 20 I1, and 20 I1 is nothing but Vx minus 12. So 3 into Vx minus 12. In this one, 60 I2, we write 2 into 30 I2. So 2 into 30 I2 becomes Vx minus 2. And then it's just a matter of resimplification. Take 6x on this side of the equation, and this minus 5x minus 3 into 12, 36. 3Vx plus 2Vx is 5Vx. And minus 36 and minus 4 is minus 40. That is equal to 180 minus Vx. We take 6Vx here, so that becomes 11Vx, and 180 plus 40 minus 40 on this side becomes plus 180 becomes 220. So we have Vx value of 220 divided by 11 or 20. And once we have found a Vx, we can substitute it in this equation. We get I1. We substituted Vx in this equation. We get I2. So we have the values of I1 as 0.4 and I2 as 0.6 ampere. And if we add 0.4 and 0.6, we get I1 plus I2, which is nothing but the current flowing in this branch.